Here we got an integral of a function that has a square root on the bottom, and there is no obvious way to do this one. We do know we have integrals that become arc trig functions that are square root of either u squared minus a squared, arc secant, or a squared minus u squared arc sine. So since this is this quadratic under a square root, we can use completing the square to get this hopefully into one of those forms. So I like, this is pretty complicated. It has a square root, so I like doing the completing the square part on the side. So here's my completing the square part. I have negative x squared minus 4x plus 1. So I'm putting it in a standard form of a quadratic. You can't complete the square until a is 1. So you'll notice here that a is a negative 1. That's an easy fix. You just factor out the negative from the entire quadratic. And now you just complete the square of what's in the brackets. So remember, completing the square is adding b over 2 squared and subtracting b over 2 squared. So b is 4. So b over 2 squared is 2 squared, which is 4. So again, completing the square is really just adding b over 2 squared. That would complete the square of this quadratic. And then subtracting the b over 2 squared is just balancing out that, so we're not changing anything. So here we go. X squared plus 4x plus, I don't know what I was doing. Yeah, b over 2 squared here. So plus b over 2 squared, which is 4. We've completed that square. Then subtract the 4. So you balance out the equation, and don't forget about that minus 1. So now we have, this is our perfect square trinomial. It factors into x plus 2 quantity squared. There's our u squared that we need for a arc function integral, and minus 5. And then I'm going to redistribute my negative right now. So this would be 5 minus x plus 2 squared. So if you think about, well, let's put it back here. It looks like it's going to be arc sine, because now this integral is just 5 minus the quantity x plus 2 squared dx. Remember this, the integral with du over square root of a squared minus u squared does become an arc sine. This is an arc sine. And the good news is it's a pretty straightforward arc sine, because u would just be x plus 2. So du is dx. So there's no constant involved with substituting the u's. A is the square root of 5. So it's a straight arc sine. We do have this 2 as a constant. That doesn't really get in the way. We'll just keep it factored out. So the arc sine formula is, this would be 1, not 1 over a. That's the arc sine's the one without the 1 over a. So this is just arc sine of u over a. U we said is x plus 2. And a is the root of 5. And that's it. That was a pretty easy one after we completed the square. So I would guess that Wolfram Alpha, since this was so easy, would completely agree with that without any like simplifications, and it does. So there you go.